Solving rational inequations. We're going to combine two different skills: graphing rational functions and solving inequations. Here we go. When we studied inequations before, we let y equal the expression. We did that because we knew how to graph this. So we'll factor that, find x and y intercepts. To find an x-intercept, you let y equal 0. The only way to make this fraction equal 0 is if the top equals 0. So the x-intercept is -1. The y-intercept, let all your x's equal 0. The y-intercept, -1/9. Then we have our asymptotes. Vertical asymptote. What is x not allowed to equal? We're not allowed a 0 in the bottom, so x cannot equal plus or minus 3. Horizontal asymptote, that's where we compare the highest power of x on the top to the highest power of x on the bottom. In this case, our numerator, much smaller than the denominator. So the answer for the horizontal asymptote is 0. An explanation for that, if you imagine x being 1,000,000, 1,000,000 over 1,000,000 squared is starting to approach 0, certainly getting very small. Let's draw a very rough sketch of this graph. We have vertical asymptotes at 3 and -3. Horizontal asymptote at 0. And then let's look at our points. X-intercept -1, y-intercept -1/9. Okay, let's start with these points. We have to connect those points and approach the asymptote. And when we pass through here, we approach the next asymptote. Now remember, when you cross an asymptote, you change your sign. So we're negative on this side of the asymptote, we'd be positive up here. So we know the graph is up there. Use the same logic over here. Positive on this side of the asymptote, change sign means we're negative down here. So there's a rough sketch of our graph. Here's a slightly nicer one. And what we do when we look at inequations is we think of the graph in 3 parts. The part where the y values are positive, the part where the y values are negative, and the part where the y value equals 0. And we're looking for greater than or equal to 0. So where is y greater than or equal to 0? That would be the blue and the black section. So this blue section starts at -3 and goes until -1. This blue section starts at 3 and goes to infinity. And let's think about the brackets. We know we can never get to infinity. Can we get to 3 on this graph? It's an asymptote, so that's a no. Can we get to -1? That looks like it's a point on the graph. It's an x-intercept, so definitely. And what about -3? It's another asymptote. You're never actually going to equal -3. So that's how you determine the shape of your brackets. Let's do another one. We'll start by letting y equal the expression and then factor. Oh, what do we do when we have the same thing on top and bottom? That's going to give us a point of discontinuity. So we'll simplify this and state that x cannot equal 2, so we remember that it's a point of discontinuity. X-intercept, what would make the top equal 0? -1. Y-intercept, I'm going to go back to here. Let all your x's equal 0. The y-intercept is 1/3, so -2 over -6. Vertical asymptote, anything that would make the denominator equal 0. -3. Horizontal asymptote, that rule, check the highest power of x on the top and the bottom and compare them. And when they're equal, do you remember that you just divide them? So when you divide those, you're going to get a horizontal asymptote of 1. Let's do a very rough sketch. Vertical asymptote, -3. Horizontal asymptote of 1. Let's put some points on the graph. The points that we have, x-intercept of -1, y-intercept of 1/3. So we're going to connect those and approach our asymptote. I think I've done something wrong there. I wonder if you can figure out what it is. And where's the other part of the graph? Are we up or are we down? 2 ways to check. Negative on this side, positive when you cross the asymptote. The other way to check is if you were to draw something here, you'd be making up an x-intercept. Now, who can figure out what we've forgotten? There's a point of discontinuity at 2. So we should have a little hole in our graph there. So remember to include that. Sometimes even the programs I use won't include them. So there's actually a hole right here. So that does not cross through at 2. There's a hole in the graph. Okay, remember what we're doing. We're solving an inequation. We look at 3 parts of the graph, the part above, the part below, and the part on. We want less than or equal to 0. So where is it less than or equal to 0? That's the red section. Whoops, and I gave you the answer. Let's see if we can come back to it. Okay. Less than or equal to 0. This graph, where is that asymptote? -3. So it starts at -3. And it ends at the intercept, so that's -1. Now, less than, not an equal sign in sight. So not a square bracket in sight. So there's our answer. Let's try another. Start by letting y equal the expression. Factor. Nothing can be reduced. Let's find x and y intercepts. X-intercepts come from letting the top equal 0. So that would be 1 and -1. Y-intercept, let all the x's equal 0, getting -1/4. Vertical asymptote, what x cannot equal and what you cannot do is divide by 0. So -4 for the vertical. Horizontal, compare the exponents when the top is bigger. That's when we say the asymptote does not exist or it goes to infinity. Why does that work? Imagine dividing 1,000,000 squared by 1,000,000. That's getting a whole lot bigger. Okay, very rough sketch of the graph. Vertical asymptote, -4. No horizontal. This is going to be interesting. X-intercept 1 and -1. So +1 and -1. Y-intercept -1/4. All right, so it looks like these should connect and we'll approach our asymptote. And what happens on the other side? We know we have to go up here. We're not approaching anything horizontal, so I think we have to keep going. Huh. And okay, it doesn't quite look like that, but we forgot something. What about the other side of the graph? Oh, silly us. Positive on this side of the asymptote, negative on the other. So our asymptote, we come up here, but where do we go? We can't cross the x-axis because there's no x-intercept. So that's why we have to head back down. So that's why it's got this sort of shape. And it's okay if your shape looks a little more like it's going up than going along those lines. This is actually called a slant asymptote, and we'll talk about those in calculus. For the moment, all we really care about is above, below, and on. So even if I had this kind of awful looking graph of mine, I'd still be able to pick out the above, below, and on. All right, what are we looking for? Greater than 0. Where is y greater than 0? That would be the blue section. And the blue section starts at, what was that asymptote again? -4. So it starts at -4. There's an x-intercept of -1. So it goes to -1. And then it's red underneath here. It's a little hard to see. It might actually be better on my fairly bad graph. And then above again from 1 to infinity. What kind of brackets? No equal signs in sight, no square brackets in sight. So let's check that answer, and that's not actually right. Huh. Oh, good for us for being smarter than the answers. So the answers to this question right here goes from -4 to -1 and from 1 to infinity. And again, you might be able to see it better here. Positive in here, positive in there. Okay, your job today This is a terrific practice section because you're going to be graphing and graphing and graphing, and you get to review inequations. So do all of them. Have fun.